we are continuing with the 4-cube classes. We are continuing the class. We have been dealing with kinematics. That is considering motion. Not necessarily being interested in the force causing the motion. So now we're going to look at the vectorial form of velocity, because a vector is that quantity that has magnitude and specific direction, unlike a scalar, which even has magnitude, but the direction is not specific. So that's what we're going to look at now. So in looking at this, we want to talk about motion that are located by bearing. Motion located by bearing. That is motion that is located by bearing. Using bearing to indicate the location of the object that is moving. Example is this. We take an example. Now, a bird that is flying at, let's say, 4 kilometers per hour. The bird is flying at 4 kilometers per hour. A bird is flying at 4 kilometers per hour and heading north. It was going north. So if I put the cardinal point to locate how the bird is going, that means the bird is going this way. 4 kilometers per hour. It's heading north. This is south. This is east. This is west. This is east. So the bird, by the question, says that the bird was heading north and encountered the wind. They encountered the wind that is blowing due east. The wind is blowing to the east. The wind is blowing to the east. The wind is blowing due east. So that means the wind is blowing towards the east. That is blowing this way. Look at the wind. It's blowing to the east. The wind is blowing to the east. The wind is blowing to the east at 2 kilometers per hour. At 2 kilometers per hour. The wind is blowing at 2 kilometers per hour. What speed will the bird eventually end up with? What speed will the bird end up with? That is simple. That's to find the resultant of this and this. And because the velocity is vector, we solve it vectorially to get the resultant. To get the resultant, we draw the resultant here. So looking at this, we bring this into, because from this, that means the two, both the bird and the wind are at right angle to each other. So if we close this, we make a rectangle. If we close this, while the resultant is the hypotenuse of the rectangle. So if we extend this 4 here, we have 4 kilometers per hour. So the resultant R is this. So that resultant R by Pythagoras would be equal to 4 squared plus 2 squared, which is 16 plus 4. 16 plus 4, that is 20. So the resultant is square root of 20. That's the resultant. The resultant is the square root, which is 4.47 kilometers per hour, which is 4.47 kilometers per hour. That is the speed the bird will eventually end up with. That's the speed the bird will eventually end up with, because it was intercepted by a wind. So, but if the bird, another one, number B, this is A. We've tried this now. We've solved this. If we want to solve another part of the question, which says that if the bird moves 6 meters per second in the northeast, if the bird moves, let me look at the cardinal point. It moves northeast instead of north. This is north, this is south, this is east. So instead of moving north now, it moves northeast. Look at the bird, direction of the bird, northeast. Look at the direction of the bird. If the bird moves northeast, 6 meters per second, 6 meters per second. It's moving at 6 meters per second. Northeast. And the wind moves 5 meters per second, northwest. The wind moves 5 meters per second, through northwest. Look at northwest. 5 meters per second. If the wind moves 5 meters per second, northwest. Now find the final speed of the wind. That is the resultant, which would be this. So this angle is still 90 degrees because this is parallel to this, this is parallel to this, and this is 90, this is 90. So if it is 90, the same way, we have R, this is the resultant. R squared is equal to 5 squared plus 6 squared. 5 squared plus 6 squared, which is 25. 25 plus 36, which is 25 plus 36. This is equal to 61. This is equal to 61. So R is equal to square root of 60. Square root of 61. Square root of 61, which is equal to 7.8 meters per second. 7.8 meters per second. That's the final speed. So let me now say the question that I just solved again. Let me now read the question. A bird flying at 4 kilometers per hour due north. That's number A of the question. Number A of the question. A bird flying at 4 kilometers per hour due north encounters a wind blowing due east at 2 kilometers per hour. What speed will the bird eventually end up with in flying? That's A. B. If the bird moves 6 meters per second in northeast and the wind moves 5 meters per second northwest, find the final speed of the bird. That's what I've just done on the